Hello everyone. Here we're going to think about doing the best you can and dividing your time. Now when we do this, we're going to approach a similar problem to a problem we approached in Chapter 3. In Chapter 3 you were choosing between living and learning, and with living you had to choose between study time and spend time on things that you wanted to do that were not to do with study time. And so here we're going to look at a similar problem, and that problem is how do we divide up the limited number of hours in our day between all of the things we would like to do or must do to make a living. Okay, so we're only going to consider two objectives here, free time and consumption. And so the trade-off between free time and consumption is going to be the pay for consumption with the wages we would make for an hour of work that we could do. So we're going to consider a worker, Scott, and Scott is going to decide how to spend his days, how to spend his time on his days. So H is the fraction of the day that Scott spends working for wages. 1 minus H is Scott's free time, and his daily consumption is X. W is the total income he would receive if he worked for 24 hours. So, right, when we think about this, that W, that's like basically saying, okay, imagine H is just 1, it's the total fraction of the day, W times H, that's what he would receive if he worked the whole day. And then we're going to see some fraction of the day that he works, and he's just going to get paid for that fraction of the day. So we're not going to talk about total hours here, we're going to talk about the fraction of the day worked. Okay, so Scott will consume his entire income. So what that means is that his consumption X equals W times H. So we're going to now examine how Scott will implement this marginal rate of substitution equal to marginal rate of transformation condition to make decisions about how to spend his time. So the first thing we want to start off with is if Scott works a certain number of hours, HA, then his wages that he receives are going to be equal to W times that fraction of the day that he spends working, W times HA, and therefore his consumption at that point is going to be equal to XA, right? And that's all corresponding to this point over here, A. So what do we think of here? F equal to 1 on the vertical axis. That's saying he spends all his time on free time. He's not working at all. So he has 0 consumption at that point. Right now, if he spends less time on free time and he does some work, so here we're saying he works HA hours, like he's not spending all of his time on free time. So he works HA hours. He reduces his free time by some fraction of the day. Then he's going to be able to get wages for that and therefore be able to get some consumption equal to XA. So that's the relationship that we're modeling here. Now, the line that we have here, that's basically saying what Scott does if he basically works for each fraction of that day and is just kind of allocating his time so that he gets the wages for that. Right? So that's basically his budget constraint here in terms of wages that he receives for the fraction of the day that he works. So let's just think about how that's working again. The feasible frontier is Scott's budget constraint, which is equal to X, his consumption, plus 1 minus H times W. Right? So what's 1 minus H? That's his free time. So remember the vertical axis is measuring his free time. And that free time is equal to 1 minus H. H is the number of hours he spends working. Right, so 1 minus H times W is less than or equal to W. Okay, so when we're thinking about this, the maximum amount of free time depends on the level of consumption, and the budget constraint is therefore going to be the following. 1 minus H is equal to 1 minus X over W. So what is that saying? We think about his amount of time, his free time. That's going to be equal to 1 divided by the amount of consumption he has divided by his wage. So that's his consumption divided by his wage, right? So what do we remember here? We knew that X was equal to WH. Okay, so that's where this relationship is coming from. Because X is equal to WH, what does that mean? It means H is equal to X over W. And therefore, when we have 1 minus H, that's going to be equal to 1 minus X over W. Okay, so just keep that in mind as we progress, because I'm going to erase that now. Okay. Now, The negative of the slope of the budget constraint is a moderative transformation of reduced consumption into more free time. Or it could be thought of as the reduced free time into more consumption. So you can go in both directions with this moderative transformation, right? So we've got the budget constraint here, and the negative of that slope, negative of the slope, that's equal to the marginal rate of transformation. Now, what is that telling us? It's telling us about the opportunity cost of more free time in terms of consumption you would forego, or it's telling us about the free time you would forego in order to get more consumption. So that's what that's telling us about. Okay. Now then, when we want to combine this with Scott's indifference curve, Scott likes both free time and consumption. Both of them are goods. So what have we done here? We said that Scott has a Cobb-Douglas utility function in terms of both free time and the goods that he likes. So when we think about this and we substitute in for this free time, 1 minus h as the number of the amount of free time he has available to himself, what this means is that free time and consumption are both goods. They have positive marginal utilities. And what do we also know? The indifference curve slope is equal to the ratio of the marginal utility. So our y variable, our free time here, we take the marginal utility of that and we think about that in the denominator. And we've got the marginal utility of x, here consumption, in the numerator. We take that ratio. We know that because this is a Cobb-Douglas utility function, the ratio of those is going to be equal to alpha over 1 minus alpha in terms of with y over x here, and that's going to equal to the marginal rate of substitution, and that's going to be equal to the willingness to pay. Now, we know we have that y over x multiplied there in terms of finding the marginal rate of substitution, but the crucial point here in terms of the alphas and the 1 minus alphas is that those are going to be telling us about the shares of the two goods in our final consumption bundle. Now, what we want to think about here is that alpha is the share of time that Scott will spend on making money to pay for consumption. That's what we're going to see here from our marginal rate of substitution. Alpha, that share, is telling us how much time he's going to spend on working for pay to get consumption. Now, what we're also able to see here is that at this point, MRS equal to MRT. What is that telling us? It's telling us about Scott's willingness to pay in his free time to get more consumption. So his willingness to give up his free time to get more consumption, the X good, that's what his marginal rate of substitution is doing. And so if we compare point D and point A, at point D, what is true? His marginal rate of substitution, his willingness to pay in his free time to get more consumption, is greater than his opportunity cost of free time in terms of consumption. So he actually would rather have consumption than free time at point D. And we can tell this by the slopes of the feasible frontier or the budget constraint and the indifference curve. And so what is it? What should he do at that point? He should increase his consumption and increase his work hours. He should give up some free time. If he does so, he will move towards the point where MRS equals MRT and he maximizes his utility. And so this is the kind of decision process that Scott goes through in terms of maximizing his utility and finding the point at which marginal rate of substitution equals the marginal rate of transformation for him in reaching a utility maximum. Now, the question that we're going to be addressing in a moment in another video is what happens when Scott is affected by social pressures? And those social pressures are to do with the subjective value of his consumption. What happens to Scott if his consumption doesn't feel as good as someone else's consumption? Maybe he is comparing himself to other people and they're consuming more than him. And he's thinking, oh, my consumption doesn't look so good anymore. How is that going to change the process that we're going to go through here? How will it change his choices about his utility maximizing number of hours of work and his utility maximizing amount of consumption? That's a question we're going to interrogate next.